Hey everyone, and welcome to another deep dive. Today we're looking at how AI is becoming more powerful and more sustainable all at the same time. It's all thanks to these things called energy-efficient AI accelerators for edge computing. Sounds pretty complex, right? Well, we've got a great source to help us break it all down, a really insightful essay by Jörg-Owe from Stanford University's Open Virtual Assistant Lab. So, let's jump in and see what we can learn.
You know what's really cool about all this? It's how this impacts you directly. Like, think about those apps on your phone that give you instant results, like facial recognition or, language translation. That's edge computing in action.
Okay, so the data is being processed right there on my phone.
Mm-hmm.
No more sending it off to some, far-off data center.
Exactly. It's a shift away from those centralized data centers. We're starting to process data at the edge, closer to where it's generated. It's all about speed, efficiency, and privacy, No more lag, less energy wasted sending data back and forth. And your sensitive data stays closer to home. And Schneepat really highlights this in his essay.
Yeah, that makes a lot of sense. But AI needs some serious brain power, right?
Yeah.
How does that work on something like my phone?
Well, that's where these AI accelerators come in. They're specialized hardware designed to make AI applications super fast and super efficient. Schneepat does a great job breaking down the different types.
Okay, so what are these different types of AI accelerators? Give me the rundown.
All right, well, first up, you've got your GPUs. These are the powerhouses, especially when it comes to parallel processing. They're famous for powering those incredible graphics in video games, and now we're harnessing that same tech for AI.
GPUs, yeah, I've heard of those. They're why my video games look so awesome, right? But what about AI that needs to be super efficient, like for something smaller than my gaming PC?
Well, in that case, you've got ASICs. They're custom built for specific tasks, which makes them incredibly efficient, although less flexible. Like Google's Edge TPU. It's specifically designed for edge computing.
Oh, so ASICs are kind of like specialists then. Super good at one particular thing. What else is there?
And then you've got FPGAs. These guys offer a nice balance between efficiency and flexibility, because they're reprogrammable. So they're gaining a lot of traction in edge computing because of that.
So it sounds like choosing the right AI accelerator is kind of like finding the right tool for the job. There's no one size fits all, huh?
You got it. It all comes down to the specific needs of the application.
This is all really cool, but I've always heard that AI can be a real energy hog, think about training those giant language models. Doesn't that kind of defeat the purpose of trying to be more efficient at the edge?
That's a really important point. And Schneepat actually lays out some pretty startling statistics in his essay. Get this. AI's computational demands are doubling roughly every 3.5 months.
Wow, that is fast.
It is, right. And the energy consumption is following suit. For example, training GPT-3, which is the model behind ChatGPT, produces an estimated 500 metric tons of CO2 emissions. It's like driving a car around the Earth over 120 times. So yeah, energy efficiency definitely needs to be a top priority as AI keeps evolving.
That definitely puts things into perspective. So how is AI accelerator design tackling this energy challenge then? What's being done to make these powerful systems more sustainable?
Well, one approach that Schneepat highlights is moving away from traditional shared memory architectures. We're moving towards distributed memory systems with on-chip message passing.
On-chip message passing.
I think.
That sounds a little technical. Can you kind of break that down for me a little? What makes that more energy efficient?
Sure. So traditional shared memory architectures, they can create these bottlenecks where different parts of the system are all competing for access to the same memory resources. And that leads to wasted energy and slow processing. But with distributed memory, each processing unit has its own dedicated memory, and they communicate with each other using on-chip message passing. So this allows for a much more efficient data flow, and it reduces those energy-sapping bottlenecks.
Ah, okay. So it's kind of like having dedicated lanes on a highway instead of everyone trying to cram onto the same road.
Mm-hmm. That's a great analogy. It makes everything run much more smoothly and efficiently. Companies like GraphCore and Cerebras are really leading the way with these innovative architectures. They're really pushing the boundaries.
Sounds like they're paving the way for a greener AI future then.
Mm-hmm.
Are there any other approaches to making AI more energy efficient? Any completely different ideas out there?
Well, there's this concept of approximate computing. It might sound kind of counterintuitive at first, but it's actually really fascinating.
Approximate computing. Okay, now you got me curious. What's that all about?
So it's all about finding the sweet spot between accuracy and energy consumption. It's based on this idea that in many applications, we can achieve acceptable results even if the computations aren't perfectly precise. It's like saying good enough is good enough, but, in a very intelligent and strategic way.
So we're talking about like cutting corners with AI. Is that even safe?
Not exactly cutting corners. It's not about being sloppy or compromising safety. It's about intelligently choosing where those approximations can be made without significantly impacting the overall performance or the reliability of the system.
Okay, so can you give me a concrete example of how approximate computing would work in the real world?
Absolutely. Imagine an image recognition algorithm for a self-driving car. It needs to identify objects quickly and accurately to make those safe driving decisions, right? Now, instead of processing every single pixel in an image with absolute precision, the algorithm could use approximate computing to kind of focus its energy on the most important areas, maybe like the edges of objects or areas with high contrast. And this allows it to save energy without sacrificing the accuracy it needs for safe driving.
Wow, that's incredible. It's like the AI is learning to prioritize, like it's focusing its energy on what matters most. But wouldn't this kind of vary depending on the AI application?
Precisely. The key is to carefully analyze the specific requirements of each application. You have to determine where those approximations can be made without compromising functionality or safety. It's a balancing act, but the potential energy savings are enormous.
I'm starting to see how all this fits together now. Energy-efficient AI accelerators, clever architectures, and even approximate computing. It's all coming together to make AI more sustainable. So what about the real-world impact of all this? Where are we seeing these energy-efficient AI solutions in action today?
That's a great question. And that's actually what we'll explore next. Get ready for some really cool examples. Well, one area where energy-efficient AI at the edge is already making a huge impact is real-time data processing. Think about analyzing video footage, as it's being captured, or processing sensor data in a factory. It's all happening instantly right there on the device, all thanks to these advancements.
That's amazing. So no more waiting for data to be sent to the cloud and back. It's like having instant insights, right at your fingertips.
Exactly. And these instant insights are unlocking some really powerful AI capabilities, like object detection. Imagine self-driving cars that can react to obstacles in a split second, or security systems that can identify potential threats in real time. It's all becoming possible with energy-efficient AI at the edge.
Wow, that's mind-blowing. It's like AI is gaining superpowers, but without the massive energy bill. Yeah. So what other real-world applications are out there? What else is this technology enabling?
Well, predictive maintenance is another big one. Think about sensors on factory equipment. They can detect tiny anomalies before they become major problems. Energy-efficient AI at the edge can actually predict when a machine is likely to fail. This allows for proactive maintenance, prevents costly downtime.
That's brilliant. It's like having a crystal ball for your machines, but powered by AI instead of magic.
Yeah.
So what about the bigger picture? How is this impacting, our cities and the way we live?
That's where things get really exciting. Think about smart cities, where homes are interconnected, energy use is optimized, and traffic flows smoothly. AI at the edge can analyze data from sensors all over the city, like traffic lights, energy grids, even trash cans, to make everything run more efficiently and sustainably.
It's like the city itself is becoming like this giant interconnected brain, constantly learning and adapting to make life better for everyone. What about robots and drones? Where do they fit into this whole edge computing thing?
Autonomous systems are another huge area where energy-efficient AI is making a difference. Drones making deliveries, robots assisting in healthcare. All of these applications rely on AI at the edge to navigate complex environments and to make decisions in real time.
It's crazy to think that all of this is already happening. It's not just science fiction anymore. But like any new technology, I'm sure there are some challenges, right? What are some of the roadblocks that we need to be aware of?
Yeah, you're right. There are always challenges with emerging technologies. Schnepphat actually goes into some of these in his essay. Scalability is a big one. As AI gets more complex and we generate more and more data, we need to make sure these edge computing systems can handle those increasing demands.
So it's like we're trying to fit a square peg into a round hole. The hardware needs to keep up with the ever-growing demands of AI.
Exactly. Schnepphat talks about the UltraScale Plus architecture. It's block RAM, which can store a lot more data, 36K, but as image resolution increases, resource allocation and latency become more complex.
Block RAM, sorry. Can you just clarify what that is?
Oh, sure. Block RAM is a type of memory that's commonly used in FPGAs. Think of it as a small, fast, on-chip memory bank that can store frequently accessed data. So as image resolution goes up, you need more block RAM to store the image data. But allocating that memory and managing the timing of data access, it gets more challenging. It's a complex complex optimization problem.
So it's not just about having enough storage. It's about making sure the data can be accessed quickly and efficiently.
You got it. And that leads to another challenge. Resource optimization. We need to squeeze the most performance out of limited hardware, especially in these edge devices, where power and space are really limited.
It's like trying to pack for a week-long trip, but you can only use a carry-on bag. Every little bit of space and efficiency counts. So how do you even go about optimizing these complex systems? It seems like a pretty daunting task.
It is. Schneppat points out that finding the optimal configuration for these resources isn't easy. It often involves using heuristics rather than trial and error, which can be really time-consuming. And then, of course, there's the environmental impact to consider. We can't forget about the bigger picture.
That's right. We can't just focus on performance and efficiency and forget about sustainability. So what are some of the key environmental challenges that we need to be thinking about?
Well, we need to go beyond just making efficient hardware, right? It's about the responsible development and deployment of AI. Thinking about the entire life cycle of these technologies, from manufacturing to disposal, and how we can minimize that environmental footprint.
So it's not just about making AI green, it's about making that entire process sustainable.
Precisely. And then there's the challenge of market adoption, getting companies to embrace these new technologies, overcoming that initial investment hurdle, making that leap into the future.
It's like convincing someone to trade in their trusty old car for a sleek, self-driving electric vehicle. There's always some resistance to change. But despite all these challenges, I'm feeling pretty optimistic about the future of energy-efficient AI. It seems like researchers and companies are working hard to make it a reality.
I agree. It's a really exciting field with so much potential to make a positive impact on the world.
As we're wrapping up our deep dive into this topic, what stands out to you the most? What's like the big takeaway you want our listeners to walk away with?
I think for me, it's that Schneppat really gets us thinking about not just the impressive tech behind energy-efficient AI, but also how it can actually lead to a more sustainable and equitable future,
Yeah, it's pretty amazing to see how much potential there is.
Yeah.
So as we wrap things up here, what's like one question you want our listeners to ponder?
Well, Schneppat's essay is all about the nitty-gritty details, which is super cool, but what if we zoom out a bit? Like, imagine if AI could be powered entirely by renewable energy. Right there at the edge, completely self-sufficient and carbon neutral.
Whoa, that's a game changer.
Yeah.
AI becomes this force for good, not just in what it can do, but also in how it's powered.
Exactly.
Well, that about wraps up our deep dive into the world of energy-efficient AI accelerators for edge computing. It's been a fascinating journey, and hopefully you learned something new today.
Absolutely.
And if you're as excited about the future of AI as we are, be sure to check out Jörg-Owe Schneppat's essay. It's a great read.
It really is.
Until next time, keep exploring, keep asking questions, and stay curious.